Okay, I think we can start. Thank you very much, and apologies for the delay. So today, what I'm going to present is an idea that we've been working lately within the EF, in particular in the stateless consensus team, and is basically trying to anticipate to the fact that when GKEVMs come, we actually have an issue, which is who's going to hold the state. So I'm going to start by mentioning briefly the status quo. Basically, now in the network, we have millions of validators, sure, but the actual amount of nodes is 13,900 approximately. So that is actually what matters with respect to geographic distribution, real decentralization, and censorship resistance, right? And so what happens is that when GKEVMs come into play in the protocol, we face now a new dilemma that is actually complex to solve, which is basically we can do execution-less verification of a block, right? And so if we don't actually even need to execute the block in order to verify that a block is correct, well, we no longer need the state anymore. So as a staker or as a node, if all I'm trying to do is attesting to blocks and proposing blocks in order to basically get some ETH in return of what I'm staking for securing the network, I'm actually in a pretty easy choice, which is will I have like a massive big NVMe with 4 terabytes to hold this thing, or will I just have like the smallest hardware I can afford, because now I no longer need to hold the state anymore and I don't need to be really fast at re-execution transactions. So that has a lot of implications. Snapsync will degrade. If a lot less nodes have state, well, all of a sudden it's a lot harder to sync the network because either you re-execute from Genesis, or if you want to do snapsync, you have a lot less nodes to query for leaf and node data. So we're basically, the summary is, if we don't do anything, what's likely going to happen, maybe not immediately, but in the long term as state grows to 1, 2, 4, 10 terabytes, is we're going to face with this, which is very few nodes will concentrate the state. Builders and RPCs are the only ones that are incentivized to hold it at the end. And the rest of people will all of a sudden disappear from the network perspective. Sure, the economic security is there, but there's actually no state, no distribution, no censorship resistance that they can come into play and provide. So let's try to imagine a different path. What if I can tell you that you can hold only what you want and you can still contribute meaningfully to several parts of the Ethereum network stack? This is what partial stateful nodes are trying to solve. Basically, the numbers that I want you to get out from with is for 59 gigs, I can have all the account try. And for example, I used USDC and DAI as the contracts that I wanted to hold. But that it's completely up to the validator or the attester or basically the staker. You can hold the amount of contracts that you want and the amount of data that you want. And we will see why this is interesting really soon. The TLDR is what you need to hold for this to be effective is you need to hold the entire account try, which is the top part of the Ethereum state. And from there, we have all of the intermediate contracts that you can decide or not to hold. And you will say, okay, but what does this give me? Sure, I keep less disk, but that's not really useful. Well, the first thing that this allows you to still do is to provide proofs for data, right? Imagine RPC world nowadays. No one really gives any proof for the data. We just trust the RPC, and we just say, okay, sure, you are giving me the correct data, but I have no guarantee. But these kinds of nodes have the capability to provide you proofs for any account data plus any storage data for the storages that they are tracking. And guess what? If you have 13,000 nodes, it's definitely cheaper for them to provide this data than it is for an RPC that is completely centralized, right? So I'm going to get a bit on how this works, and then I'm going to quickly go to how we can actually profit from this design from the economic perspective, which is what at the end to a lot of stakers matters. How this works in a nutshell is we snapsync only the account try, which is the top part of the Ethereum state, basically. And once we have synced that, we basically have all the middle ground that will allow us to do MPT proofs for any data that we want to then keep. After that, when we have synced the account try, we sync only the storage slots that we are interested on. After that, and thanks to block access lists, then we can pivot on actually following the chain without actually re-executing with our CKEVM node, for example. But the detail is block access lists are giving me all of the deltas on state that I need in order to keep my tree up to date. So basically, my storage is up to date, I don't re-execute anything, and I can still act as an RPC for the rest of the network. And so I just wanted to briefly mention that there's a lot of people that thinks about state expiry being this solution that will basically save us all. But I will put a really quick example here. What happens if you are a user and your balance has basically expired and you want to make a transaction? What do you think the RPC or the wallet needs to do in order to allow you to revive this and actually use it? Well, what they are going to do is they are going to hold the expired state and they are going to hold the actual real state or the hot one. And what they are going to do is they are going to bundle the revival transaction with the transaction that uses this balance, and they will send it to a builder or whatever it is. But the TLDR is they hold both trees, the expired one and the non-expired one. So there's actually no real benefit because the actual end users will need to still hold all the data. And when this is terabytes, it's going to be a mess. But if we actually distribute the data with different strategies across an entire network of validators without putting terabytes on top of them, we're actually decentralizing and distributing the state, guided by markets and by market incentives, and we can still hold all of these data availability, to put it on some sense, for the entire network. So what partial statefulness enables? Well, the first thing is inclusion lists for Fossil, right? Right now, if I want to participate in Fossil, which is going to hopefully ship in Hegota, if I'm not mistaken, there's this role called includer. And what the includer does is it looks at the mempool and it basically says, okay, there's all of these transactions in the public mempool. Now I'm going to include them in a list and I'm forced the builder to include these transactions in the block so that I cannot be censored. And the whole point of that is if the builder doesn't include them, then the fork choice fails and the prover doesn't get any reward because the block is not valid, right? So sure, that's really cool, but if all of a sudden everyone is a CKEVM node and holds no state whatsoever, who is actually going to build these inclusion lists? Because you need to make sure that the transaction is valid in order to include things in the inclusion list. But in order to know that the transaction is valid, you actually need to know the balance and the nonce of the account. So if you don't have that, basically, you can put garbage on the access list, and there's no censorship resistance whatsoever. Like, it can just be bypassed. So this is basically what I was saying, like all of the checks that you basically need to do as a node to make sure you can include a transaction in the inclusion list. And hopefully, well, actually, this is factual, a partial stateful node can basically monitor the mempool and can build these inclusion lists such that we can still provide censorship resistance besides also data availability. This is the last part I wanted to focus. Sorry, I've speed run a bit, but I wanted to mention a lot of stuff, which is state markets. And this to me is, I think, the catching point for stakers. As a staker, I actually don't get much, besides some lottery blocks or whatever, I don't really get much from building blocks. What I get money from, or ETH at the end, is the compounding of all of the attestations that I do in a year. I mean, especially if you're a solo builder, that's certainly the case for you because you're probably making like $5 out of a block that you mine like once every 6 months or something like that. So what if we envision this partial data that we hold in the nodes as a way to compete or outcompete, actually, RPCs in state markets? You can choose any strategy that you want as long as you hold the account dry. You can select whatever contract you want in order to hold in your state. And then you can participate in state markets guided by whatever. It can even be a centralized party at the beginning that acts as a load balancer. But basically, you will consistently outprice and outcompete any RPC provider because there's just no way they can keep up producing not only the data that they want, but also giving proofs for it, such that they can make sure that the data is actually valid. Now you can say, well, this is not a problem right now, right? I mean, I trust my wallet and there's just no issues. The wallet trusts the RPC and there hasn't been any issues. Sure, but Once this gets a lot more attention, once AI agents start transacting on chain and they start querying for a lot of data that they don't have, we enter in a situation where maybe we have 400 million accounts nowadays in the state tree, but we have billions and billions and billions of accounts in the account tree in the future, and they are all active because it's all agents, for example, using them. So what happens here is the demand for state completely outgrows the amount of providers that we not really have in the network at the moment, which is RPCs. And this is a really good way to actually say, okay, I might hold all the hot state such that I give a lot of state very cheaply to a lot of people during the entire year. There's going to be other strategies where there's this cold state that almost no one touches, like, I don't know, CryptoKitties, like almost no one touches this anymore, right? But when someone does, you will have this data and you will outcompete in pricing to RPCs, while at the same time being consistently selected as the data provider for this region of the state versus other actors in the state market network. The big difference to me with Portal in particular is that this is actually incentivized. You have an incentive to keep state so that you can basically provide high quality data which RPCs are not giving you because you don't have any proofs, and you can basically outprice them as a whole network, getting really tiny benefits. But the point is, you need the machine on anyways. You need to have the machine running a testing. So you might as well just serve state and get a compounding revenue that accumulates over time versus not doing anything, which is the default case. I had some ideas on who buys state, but for the sake of time, because I think I'm close to the limit, we will skip. And finally, the last thing that from the protocol perspective I'm really interested on is natural redundancy. So basically, when market guides the data distribution that nodes have, it's actually really nice how it always tends to actually completely distribute and get the entire state at the end. And this is really interesting from a protocol perspective because we can keep censorship resistance really, really high, because at this point, even if you have fossil, if we are dominated by 3 RPCs and 3 builders, and they don't want to give me the state, there's no way on earth I'm going to transact and interact with that part of state. So fossil is useless, basically, right? So I think this part is what I really like and I'm interested in about the protocol. You can see you can have all sorts of different distributions, like, I don't know, someone might decide to have USDC, USDT, and like really used tokens or frequently used tokens. Someone might decide to have like really weird things that we don't even know, but they're actually from time to time, there's some usage, and they will have to price a bit higher, and they will get slightly more benefit than when you serve a state that is actually extremely distributed and replicated. Yeah, there's some minimal requirements if you want to basically be an includer. That's related to VOPS. I encourage you all to check the article in ETH Research, but this is basically a subset of a partial stateful node. So with a partial stateful node, you can do mempool management, fossil inclusion, so you can do everything that a VOPS node does. And for the design space, the only trade-off that we currently have is account abstraction, which is basically an issue because it's going to introduce storage inside of the account trie. So every single account that wasn't a contract, now all of a sudden it's a contract, basically, to the perspective of the protocol. There's solutions, there's different strategies, there's different alternatives, scheme transactions, frame transactions, there's all the drama in ACD now, so we'll see what happens at the end. But I want to say that we are working hard on making this compatible. Whatever is shipped, it will be compatible with partial stateful nodes, no matter what, because this is the only way we can actually keep the network significantly decentralized when ZK-EVMs come into play. And so, I don't know if I have time to say this, but 4 minutes, okay, we're really good, surprising. This is not a silver bullet, right? There's types of state queries that are really amenable to partial stateful clients. Like, sure, I'm making a transaction, I need to know my balance, I need to know my balance in some contract for my tokens or whatever it is. When you enter the DeFi territory, there's all of a sudden a lot of contract interactions, and you all of a sudden need a lot of state, meaning you make a swap, you need the state of all the pools, you need the bytecode of all the pools, you need the bytecode of all the ERC20 contracts that can ever be traded. So it becomes increasingly difficult to actually serve all of this state meaningfully. Thankfully, we have this notion of this load balancer. So basically, my vision is you will make a query to the load balancer, and the load balancer is going to be like, okay, this person has this part, this other has this part, this other has this part. I'm going to make you all requests for this subset of the state, and then my only job is to batch the Merkle-Patricia proofs such that I can, at the end, deliver a single proof and all of the state together to the end user. Notice this is significantly faster and much more parallelizable because it's not the RPC computer actually giving me the proof. It's multiple computers computing different parts of the state and computing a different part of the proof for it, and therefore we unified it at the end. So we can get, at the very least, logarithmic, which is definitely better than linear. And I don't know if you've tried, but if you query an RPC for an ETH-GET proof, if they give it that to you even, this is a miracle. And if they give it, try to do it 10 to 100 times, and you will all of a sudden see that you are quickly encouraged to pay money in order to get all of this. So this is really where I see these kinds of partial stateful nodes outcompeting the current ecosystem. And finally, I want to say this is already working. In BalDevNet 3, we have our Geth node in a partial stateful mode. It basically has also synced with the tip of the chain in mainnet, although we cannot follow the tip yet because we don't have block access lists. But in BalDevNet 3, we are fully synced. And just to allow you to have some numbers when you go out of here and remember, notice that we have a node for 59 gigabytes that holds less than 79% of the entire state of Ethereum. And this actual node is capable of staking, is capable of executionlessly following the tip of the chain thanks to ZK VMs, and is capable of joining any state market following any strategy to actually get an extra revenue on the same way we get it from attestations serving a state. And if you're going to have your computer on anyways, it's just absurd to basically not become this type of node. Like, you might as well get something extra than get nothing. I mean, it just doesn't make sense. So try it. If you can, please break it, because otherwise it's really hard for us to actually make sure that there are no bugs or we haven't overseen anything. And yeah, if you have any questions, I will be extremely happy to answer. Just shoot me an email or contact me in Telegram, whatever it is. I'm really happy to interact with the staker community and actually make sure that we are meeting their requirements and hear whatever suggestions they have for us. So yeah, that will be it. Thank you very much.